Okay, this is moving on to 9.3. We're going to have a quiz over this, or we're going to have a quiz here soon just on sequences. This is the other type of sequence we're going to focus on called geometric sequences. Remember that a sequence is just a series of numbers formed by a pattern. An arithmetic sequence is when the pattern is addition or subtraction. Here we see that a geometric sequence is a sequence formed using multiplication as the pattern. Okay, and the pattern number is called the common ratio now in this situation. Okay, we're again going to be able to write explicit and recursive formulas for both of these. Let's start with the recursive formula. Remember, recursive formulas are really not all that useful. They just describe what's happening in the sequence. Okay, so here our recursive formula is going to be that the nth term of sequence A is again equal to the term right before the n minus 1 term, and we're going to go times r. Okay, and again, the only thing that you need to plug in here for is the r, where r stands for the common ratio. Okay, so if I had something like, say, this, okay, here, of course, the pattern is to times 3 each time. This is why this is a geometric sequence. The recursive formula would be that the nth term of A is equal to the n minus 1, or the term right before it, times 3. That would be the recursive formula. Very, very easy. Okay. Now, the explicit formula, which is actually very useful. It can always be used to find any term of the formula, or of the sequence, sorry. The explicit formula for a geometric sequence, to find any term, to find the nth term, or whatever term you want, you just need to start with the first term, a of 1, and now we're going to multiply by r to the n minus 1 power. Okay, so let's say, for instance, that I wanted to find the 8th term of the sequence above. Okay, well, its explicit formula would be that any term, the nth term, would be the first term, a of 1, 2, times that pattern number, or common ratio, of 3 to the n minus 1 power. So if I wanted to find the 8th term, I would just do 2 times 3 to the 8 minus 1, or 7th power. So I can take my calculator here. Let me move this video to the other side so you can see I've got 2 times 3 to the 8 minus 1, or 7th power. The 8th term there would be 4,374. Let's see. If we had, let's do one more. If we had this. Okay, the recursive would be that the nth term is equal to the term right before it, the n minus 1 term. In this case, the r, the pattern number, is of course 2 times 2. So there would be my recursive. My explicit formula would be that the nth term is equal to the first term times r, which again is 2 to the n minus 1 power. So if I was asked to find the 10th term, I would say, okay, the 10th term is equal to 4 times 2 to the 10 minus 1, or 4 times 2 to the 9th, 4 times 2 to the 9th power. The 10th term there would be 2048. Okay. All right, a couple things just to other small things that are in this section. First of all, the geometric mean. The geometric mean between any two numbers is the square root of their product. Okay, so the geometric mean between two numbers x and y is the square root of x times y. All right, so if I wanted the geometric mean of, let's say, 48 and 3, all I would need to do is take the square root of 48 times 3, which we can type this into the calculator very easily. Square root of 48 times 3. The geometric mean of those two numbers is 12. Okay. Now, doing these types of missing problems. So let's say that it asks you to find the missing terms. Of the geometric series, of the geo sequence, sorry. They would have to tell you that it's geometric. And let's say that we have this situation here. Okay, well, again, let's just think about this and we'll be able to set up an equation, okay? We're starting at 2. We know it's geometric, so we're timesing by r to get to that box. Then we're timesing by r again to get to that box. Then we're timesing by r again to get to negative 54. So what we have here is we started with 2. We multiplied that by r 3 times. Now that's not 3r, it's r times r times r, which is r to the third. And that equals negative 54. I'm going to solve this for r, and then I'll be able to fill in my boxes. So first I'm going to divide by 2. I've got that r to the third equals negative 27. Now when I cube root, opposite of cube is to cube root, I've got that r is equal to negative 3. So if I multiply 2 by negative 3, I get negative 6. Multiply by negative 3 again, I have 18. And then if I multiply by negative 3 again, I'd be back to negative 54. Okay. So we're going to review tomorrow and quiz on Wednesday.